Make search smarter with Synonyms and BM25. By the end, you will see how a simple pipeline expands queries with synonyms, how that changes ranking, and how BM25 refines relevance using term rarity. You will get a reproducible toy example you can run and a clear path to tune parameters. I'm Professor Pi, teaching search and IR from basics to advanced in simple Python. Query expansion matters because it boosts relevance and recall for real users who use different words for the same idea. It directly optimizes ranking quality and recall, and it helps tail queries hit useful documents. The trade-off is noise and latency. More terms can mean slower scoring and more false positives, and index build time grows with complexity. Intuition first. Add sensible synonyms to catch more matches. Then let BM25 downweight common words and favor rare informative terms. We will build a small pipeline over a toy corpus of short product descriptions that first ranks by exact matches, then expands queries with synonyms, then re-ranks with BM25 to print top hits. First, we will rank documents by simple exact term matches. This snippet shows a bare-bones ranking that counts how many times the query terms appear in each document from our small product description corpus. It tokenizes the query and documents using the same simple tokenizer, then scores documents by raw term match counts and sorts them highest to lowest. This is the baseline every search engineer starts with because it is easy and fast. The main knob here is the number of results to return. Raising that number increases recall, but exposes more low-quality hits, while lowering it gives a tighter, higher precision result set. Next, we will expand the query with a small synonym map to broaden term matching. This snippet constructs a simple synonym map and uses it to expand the original query into a larger set of candidate terms. For each word in the query, the code looks up one or two synonyms, then unions those with the original words to form an expanded query set. This is intentionally conservative. Adding a few close synonyms reduces the chance of noise. The adjustable parameter here is the synonym depth or list size. Adding broad synonyms increases recall, but also risks matching irrelevant documents, while a compact synonym list keeps precision higher. Now we re-rank the corpus using that expanded set of terms from the previous step. This snippet takes the expanded query terms and recomputes document scores by counting matches against that larger set, then reorders results accordingly. You will see documents that missed the original query surface because they used a synonym now move up. The practical control is weighting. You can give original query terms higher weight than synonym terms to prefer precise matches, or keep them equal to favor breadth. Increasing synonym weight raises recall and may surface more diverse results, while reducing it keeps the original intent stronger. Next, we compute BM25 IDF weights for the expanded query terms to make scoring smarter. This snippet calculates inverse document frequency for each term in the expanded set, which measures how rare a term is across the corpus, and prepares BM25 components for ranking. BM25 is a ranking function that blends term frequency and inverse document frequency with document length normalization to produce relevant scores. The key parameters are K1, which controls term frequency saturation, and B, which controls how much to normalize for document length. Raising K1 makes term frequency matter more, while changing B shifts how much long documents are penalized or rewarded. Finally, we apply BM25 scoring with the expanded query and show the top results. This snippet uses the BM25 formula over the expanded query to score each document, sorts by BM25 score, and prints the top-ranked items from our toy product description corpus. Because BM25 uses IDF, rare but meaningful synonyms get extra influence, and document length differences are normalized, so short, targeted descriptions are not unfairly disadvantaged. The practical knobs are the BM25 K1 and B values, and the number of top hits to return. Tuning K1 and B changes sensitivity to term frequency and length, which directly affects precision and recall trade-offs. Recap: query expansion adds synonyms to increase recall. BM25 then reweights matches by term rarity and document length for better ranking. Use this approach when user language varies or when recall for tail queries matters. One caveat: added synonyms can add noise and latency, so validate changes with relevance metrics. Next step: tune BM25 K1 and B on a validation set and compare NDCG or precision at 5 for different synonym lists to find a sweet spot between recall and precision. If practical, hands-on IR helps your projects. Subscribe and watch the rest of the information retrieval playlist.